Okay, so multiplying polynomials and closure. Today we multiply polynomials. Yep. Okay, so these are some of the more simple examples. If we have 5w times negative 7w plus 3 and negative 2w times 13 minus 9w squared, well, we can just distribute that. This is basic distribution. And I wrote this all out. You can probably do it in your head, but that means here, this is going to be 5w times negative 7w. And then 5w times 3 from this one. From this one, that negative goes with it. So it's negative 2w times 13 and negative 2w times 9w squared. And then just finish multiplying it out. 5 times negative 7 is negative 35. W times w is w squared. 5w times 3 is 15w. 2w times 13 is negative 26w. Negative 2w times negative 9w squared is negative times a negative is a positive, so that's positive 18w cubed. And then we're just going to combine like terms and put this in standard form. So first I put it in standard form. Remember, standard form is when the exponents go from greatest to least.
May I please have Jonathan Kraft call the main office at 66402?
Greatest to least. Sorry, I should have paused it while she went on that, but let's make it feel like school, right? So standard form means exponents go from greatest to least. Okay, 3, 2, 1, 1. Then we can combine these two. So when we combine those, we end up getting negative 11w. Pretty neat. Let's go through this one a little bit quicker. So we can distribute that negative 2r. And we can distribute this negative sign right here. This is why I did this one. This negative sign has to be distributed into there. Okay, so when we distribute it, I have negative 2r times r cubed, which ends up being negative 2r to the fourth. Negative 2r times negative 6r squared is positive 12r cubed, because a negative times a negative. Negative 2r times 6 is negative 12r, and then 4r cubed, and then distribute this negative inside of there, which I did right here, but that, becomes negative 5r to the fourth minus 10r. Okay, and then put it in standard form, so get all your exponents that are alike next to each other, and then combine like terms. So we end up getting negative 7r to the fourth plus 16r cubed minus 22r. Cool? Okay, this one. We have this double parentheses here. And I'm just going to write this out. I think it works a little bit better when I just write it out. So here, we have this negative 5r. We want to work inside these parentheses first. So let's distribute that. Negative 5 times 3ab is negative 15ab. Negative 5 times negative 2b squared. Negative times a negative is a positive. And then we still just have the b squared. And I'm going to bring everything else down. So I have the 4b, then 2a squared, and then plus 29ab squared. Okay. Now I need to distribute this into all of these. So 4b times 2a squared is 8a squared b. 4b times negative 15ab, well, 4 times 15, let's think, well, 15 times 2 is 30, and then, so 15 times 4, you just have to double that, that's going to be 60. So that's going to be minus 60a, and then b times b is b squared, and then plus 10b squared, plus 29ab squared. Pretty slick. Then combine like terms, so we have this one and this one. That can't combine with anything, and neither can the 10b squared, so 8a squared b. Negative 60 plus 29. Well, if I did 60 minus 29, let's do 60 minus 30, or negative 60 plus 30, that would be negative 30. So if I do 29, that's just one less. So that's going to be negative 31 ab squared plus 10b squared. Sweet. Let's click through this, see if we get the same answer. So we distributed that. Awesome. Distribute that. Awesome. And then we end up with 8a squared b minus 31ab squared plus 40b cubed. Cool. Same thing. Okay, multiplying a binomial by a trinomial. My math teacher, after I explained to him how, or her, I'm a girl, how I used a different method to get the same answer. Amazing, every word you just said was wrong. I'm not going to have that reaction. If you do it in use a different method, completely fine. I do not care. I'm just kidding. Okay, so here, I'm going to use the box method. I tend to lean towards the box method. I like that one the most. So I have x squared plus 3x minus 6 and x squared plus 4, or x plus 4. So this is just multiplying the sides of the boxes. So x squared times x is x cubed. 3x times x is 3x squared. Negative 6 times x is negative 6x. X squared times 4 is 4x squared. 3x times 4 is 12x. And negative 6 times 4 is negative 24. Pretty slick. So then we just combine like terms. So here, x cubed, there's nothing to combine it with. I can combine those two. That's where I get that 7x squared. I can combine those two. That's where I get the 6x squared, or 6x. Okay, this one, same thing. Let's use the box. So 5a squared plus 2a minus 6, 3a plus 1. Well, 5a squared times 3a is 15a cubed. 2a times 3a is 6a squared. Negative 6 times 3a is negative 18a. 5a squared times 1 is 5a squared. 2a times 1 is 2a. And negative 6 times 1 is negative 6. Again, we can combine like terms here. So we have 15a squared. And then 5a squared plus 6a squared is 11a squared. 2a minus 18a is negative 16a. And then the negative 6. Sweet. Okay, now this is going to be a little longer, but it's okay. So if we have that little 3 up there, that means that we have 3 of whatever is in the parentheses. So since the parentheses is 3x plus 4, we have, or 3x minus 4, we have 3 of the 3x minus 4s. Okay, and I'm going to take 2 of them, and I'm going to multiply those 2 together. And I'm just going to use the box. So if I use the box here, I end up with 9x squared minus 12x plus 16. I'm going to go a little faster, but I think you guys know how to do this. So then that part is going to end up being 9x squared minus 24x plus 16. Now I still have that 3x plus 4, or minus 4. Why do I keep messing that up? So this, I could have just written it down here. And I need to multiply these 2 together, or I just redid it up here because these 2 right here became this one right here. Okay, so now I'm going to multiply a binomial by a trinomial. So I have 3x minus 4 times 9x squared minus 24x plus 16. Multiply it all out. 27x cubed, negative 72x squared, 48x, negative 36x squared, 96, and 64. Combine like terms here. So these 2 combine to give us negative 108. These 2 combine to give us 144. Okay, so it's like a 2-step multiplication problem. If that was to the 5th, it might be like a 3 or 4 step. Okay, let's try another one. So let's try this one. This is to the 4th. So if that 4 there, that means that we have 4 parentheses that look just like that. So we have 2x minus 3 4 times. Now, since I have these 2 that are the exact same, the 2x minus 3 times 2x minus 3, and I have another one of that, let's just multiply 2x minus 3 by itself once. We end up getting 4x squared, negative 6x, and 9. So it's going to be 4x squared minus 12x plus 9. Now, that is going to replace the first blue underline. And then the second one's going to replace the second blue underline. So now, instead of up here, we were multiplying a binomial by a trinomial after we did this. Here, we're going to multiply a trinomial by a trinomial because this just got replaced by there, and this was right there. Okay. Then here, multiply this all out. I like using the box, especially for questions like this, because it helps keep it organized. So 4x squared times 4x squared is 16x to the fourth. Negative 12x times 4x squared is negative 48x cubed. 9 times 4x squared is negative 36x squared. Negative 12x times negative 12x is 144x squared. 9 times negative 12 is negative 108, and then 9 times 9 is 81. And then finish by combining like terms. Okay, sorry I went kind of fast right there. I'm just assuming you know how to do that. This is more about just the method, I guess. And so once you combine all of those, you end up getting 16x to the fourth minus 96x cubed plus 216x squared minus 216x plus 81. Wow, look at all that hard work. I'm impressed. Kind of funny. Okay. So, last thing we're going to talk about right now is closure. Okay. So, let's just think about what closure means. Like, when you hear the word closure, you might think of like a friendship ending or a relationship ending, and you had to get closure from that relationship. An act of closing, the condition of being closed. An often comforting or satisfying sense of finality. So what I was just talking about. Something that closes. French closure. I don't know. The property that a number system or set has when it's mathematically closed under an operation. So this is the definition that we are looking for. That's what I've noticed about a lot of things in math is that they have a lot of the words, if you look at other meanings of that word, maybe in different contexts, they kind of somehow mean the same thing, okay? Or this one, a set that consists of a given set together with all the limit points of that set. That's also kind of true for math, okay? So what the heck does that mean? So basically, the property that a number system or a set has when it's mathematically closed under an operation. So closure is when an operation, such as adding on a set, always makes a member of the same set. Okay, let's go through an example. Are the integers closed under addition? What the heck is an integer? Okay, an integer is just a whole number. Positive or negative is just a number. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to infinity and down to infinity. Those are the integers, okay? We want to know if they're closed under addition. So basically what that is asking is if we add two integers together, will we always get another integer? Well, let's check it. So 1 plus 2 is 3. 3 is an integer. Yes, 1 and 2 are integers. Cool. Let's try another one. Let's do something crazy. So 314 plus 913 equals 1,227. Still get an integer. Cool. Let's do a negative. Negative 42 plus 87, I get 45. Still an integer. That was enough to convince me. Oh, I did another one. Negative 42 plus negative 871 equals negative 913. So yes, those are closed under addition. Are they closed under subtraction? Well, let's check. So if we subtract two integers, will we always get an integer? And the best way to do this is to just check. So 1 minus 2, I get negative 1. That's an integer. 314 minus 913, I get negative 599. Yep, that's an integer. Negative 42 minus 87 is negative 129. Yep, still an integer. Negative 42 minus negative 871 equals 829. It's actually a positive because remember, a negative minus a negative is a positive. Still an integer. So, yep, the integers are closed under subtraction. Okay, What about multiplication? So if I multiply two integers together, will I always get another integer? Well, I did a bunch of them. So 1 times 2 is 2. 314 times 913 is that big number. And you can see here, I'm always getting integers. They might get big or really small, but they are all integers. So, yep, says Cookie Monster. My dog is literally a Cookie Monster. He literally steals food off the table, like steals cookies off the table. I'm not lying. I don't know if you guys have seen the video of a doodle who like gets up on the counter and opens the cookie jar. That is literally my dog. He is the devil. Just kidding. He's the cutest devil in the world. Anyways, so our integers close under division. Well, let's see. So that means if we divide two integers, will we always get another one? 1 divided by 2 is 0.5, which is 1/2. Well, that is not an integer. So nope, says a really cool monkey. You will not always. So that means that the integers are not closed under division. Okay, we're going to go over this with polynomials probably in class tomorrow. So we are all done, dude. Bye.